Assalamualaikum and good day to Dr. Manal. My name is Nurifa binti Rizwan, A173952, together with my team members, Nur Shazliza binti Ahmad Sharoni, A174008. Today, we would like to present the production of methyl ethyl ketone MEK. Now for the introduction, methyl ethyl ketone MEK is also known as 2-butanol and has a chemical formula of C4H8O. MEK has a molecular weight of 72.11 gram per mole and exists as liquid phase at room temperature. MEK is an organic compound that has a fast evaporation and excellent solvent properties. The boiling point of MEK is 79.64 degrees Celsius and density of 0.805 gram per ml. MEK have a short atmospheric lifetime, approximately 11 hours, because it has high reactivity, and it commonly used as liquid solvent and valuable in formulating high solid coatings which help to reduce emission from coating process. MEK is also approved as indirect food additives for adhesives and polymers. MEK is also used as an industrial cleaning agent in synthetic rubber industry. This figure shows the molecular structure of MEK.
Next, for market analysis, the MEK demand in 2022 is 1.95 million tons, and this value is expected to grow at a healthy CAGR of 4.8% through the forecast period of 2030. The MEK supply in 2022 is 1.7 million tons, and this value also expected to grow at a healthy CAGR of 4.62% through the forecast period of 2030. This figure shows the supply and demand of MEK from 2022 until 2030. As we can see here, the supply and demand of MEK was increasing every year. For plant capacity, in the coming year of 2026, the plant capacity of our MEK is estimated as below. First, we calculated the global deficiency of MEK by using the formula of demand minus supply, and the value we get is 315,600 tons per year. And our production time a day is 24 hours, and 1 day for every month we use for maintenance purposes, so that our production times per year is 8,472 hours. Our company is planning to fulfill the 10% deficiency of global demand for MEK, so that our plant capacity is 3,725 kg per hour. Next, process description. The production process we choose is vapor phase dehydrogenation process because it is more economical compared to other processes and can achieve high selectivity of MEK, which is 95% and 90% of feed conversion. This process also only need moderate temperature and can occur at atmospheric pressure. Zinc oxide will be required as catalyst. In this process, raw material needed is 2-butanol, and then it will produce hydrogen gas as byproduct, and 99% purity of MEK is a major product. This reaction is an endothermic and reversible reaction. For the production process, liquid 2-butanol will initially preheat in a steam heater in order to increase its temperature until 500 degrees Celsius. At 500 degrees Celsius, liquid 2-butanol will convert its phase into vapor phase, and then the vapor 2-butanol will then enter pipe-back reactor in order to undergo vapor phase dehydrogenation reaction with presence of zinc oxide as catalyst. During this reaction, 2-butanol will convert into MEK and hydrogen gas at conversion of 90%. The outlet of this reactor will be consist of vapor mixture of MEK, unreacted 2-butanol, and also hydrogen gas. The vapor mixture then will be entered to cooler in order to reduce its temperature from 500 degrees Celsius until 150 degrees Celsius before entering condenser. At condenser, the vapor mixture temperature will further reduce until 28 degrees Celsius. At 28 degrees Celsius, only MEK and 2-butanol, which is unreacted 2-butanol, will be converted into liquid phase. Then the mixture will then enter phase separator in order to separate hydrogen gas from the liquid MEK and unreacted 2-butanol.
After phase separator, MEK and 2-butanol, which is in liquid form, will enter the distillation column 1. The operating condition for distillation column 1 is 90 degrees Celsius and 1 atm. The boiling point of MEK and 2-butanol is 79.64 degrees Celsius and 100 degrees Celsius respectively. Since MEK is more volatile than 2-butanol, it will exit from distillation column 1 as distillate together with some of 2-butanol and enter the condenser. The remaining 2-butanol, which is in liquid form, will be exit from distillation column 1 as the bottom products. After MEK and 2-butanol has been condensed, it will enter the distillation column 2 for the final purification process. The operating condition for distillation column 2 is 90 degrees Celsius and 1 atm. From this process, 99% of pure MEK will be distilled as final product and enter the condenser, while the remaining 2-butanol will be exit as bottom products and will be recycled to feed storage tank. The final product, which is MEK, will be condensed into liquid phase and will be stored in the product storage tank. Now for the environmental issues, storage and material handlings, the first material is 2-butanol, which is our raw material. It is not classified as hazardous to the aquatic environment, and the user need to be provide adequate ventilation and use safety goggle with side protection and suitable gloves. The storage of 2-butanol is the container need to be tightly closed in a dry and ventilated place and away from heat, sparks and flame. The second material is our product, which is methyl ethyl ketone MEK. It quickly reacts with other compounds in the air and exhibits a mild acute toxicity on aquatic life, and it does not bioaccumulate. The user need to avoid contact with skin and eyes, and ignition sources exposure need to be prevented. The user need to provide adequate ventilation as it might be toxic. The storage for MEK is the container need to be tightly closed in a dry and ventilated place and away from heat and stored at ambient temperature. The third material, which is our byproduct, is hydrogen gas. It contributes to climate change by raising concentrations of greenhouse gases. The user need to put on PPE and provide adequate ventilation as well as not puncture or incinerate the container. The storage for hydrogen gas is it need to be protected from sunlight and stored in ventilated place. It also need to be kept separated from incompatible substances such as metals and oxidizing materials.
Next, for Sustainable Development Goals, SDG, there are several goals that we can be implemented in our plan in order to promote sustainable practices in MEK production plan, such as SDG 7, SDG 9, SDG 12, and also SDG 15. For SDG 7, which is affordable and clean energy, it can be practices by reuse the hydrogen gas, which is our byproduct, as furnace fuel. Other than that, we can use renewable energy sources and promoting circular economy principles. For SDG 9, which is industry, innovation and infrastructure, it can be implemented by foster a culture of continuous improvement and innovation, and also we can design products for easier disassembly, engage with research institutions and sustainability networks to collaborate. For SDG 12, which is responsible consumption and production, it can be implemented by develop and implement effective waste management strategies. Other than that, we can also reduce our waste generation by recycling and reusing materials. Lastly, for SDG 15, which is life on land, it can be implemented by properly disposing of hazardous waste to protect environmental, human health and safety. Other than that, we can also reduce greenhouse gas emission by using cleaner energy sources such as solar power. For conclusion, MEK is an organic compound that has a fast evaporation and excellent solvent properties. The global MEK market witnesses a demand of 1.95 million tons in 2022 and expected to grow at CAGR of 4.8% through the forecast period of 2030. MEK global supplies are expected to increase with a CAGR of 4.62% from 2023 until 2030. Our plant capacity is 3,725 kg per hour in order to fulfill 10% of global MEK deficiency. The main raw material used in this process is 2-butanol, and our byproduct is hydrogen gas that will be used as fuel furnace. The type of process used in this plant is dehydrogenation of 2-butanol, as it can give high conversion and better yield compared to the other process producing MEK. The catalyst used in this production is zinc oxide, and the reaction is endothermic, and this process producing MEK in a liquid phase with 99% purity. In Chapter 4, environmental issues and material handling and also storage are discussed. Lastly, there are several goals that can be relevant to promoting sustainable practices in the chemical industry, including MEK production, which are SDG 7, SDG 9, SDG 12, and SDG 15. That's all from us. Thank you.